Okay, so I'm just going to go through a full-length practice exam. So find the prime factorization of 72. So this will be the no calculator section. So 72, I'm going to do a line. I can divide by 2, 36. 2 again, 2 again, 1. Okay, so the prime factorization, I've got that 72 is equal to 2 to the third times 3 to the second. Okay, so that's the answer right there. Okay, that's the prime factorization. Now, because of the work you did for the prime factorization, you could actually use this work up here to solve the next problem. I'll make it so that happens. So you're going to solve this. So I do 2 times negative 36. Okay, so I'm getting negative 72. Okay, so I want two numbers that multiply to make negative 72, but then they have to add to make negative 1. And, you know, just from this up here, I could see some factor pairs. So factor pairs would be, well, actually, you could go like this. You could just like identify a number on the left side. Okay, so say 9. I'll cross off what's to the right. So it's going to be 9 times everything above it. So 9 times 8 is 72. All right. So you could go up the tower, you know, to figure out factor pairs, or you could just like rearrange these primes over here, you know, into two different groups, but like rearrange them, and that will also give you factor pairs. All right, so anyway, yeah, so 9 and 8 make 72, 9 times 8, but I need a negative 1. I need them to add to make negative 1, so that. So 2x squared.
Good morning, Savers.
Uh-oh,
we
sorry.
have virtual reality set up in the library for career development. Please come on down.
Oh, that sounds fun. Okay, plus I could take out a 4. Okay, so I'm getting x plus 4. So x equals negative 4, x equals 9 halves. Okay, so I skipped a move. I skipped a couple moves. So in my head, I set each of these equal to 0 separately and solved. And over here, in my head, I added the 9 to both sides, and then I divided by 2. So that's how I got that. Okay, so I did some mental moves. All right, so then when you're taking the test, then you'll give me this when you're done with that part, and then you may use a calculator on this part, but not a graphing calculator. That would defeat the purpose of sketching the graphs. Okay, so the first two are going to be rewrite as a piecewise function. Okay, so, all right, so what you do, guys, is, I'll go off to the side here. So f of x, and it's optional to rewrite this, but we're going to rewrite it as a piecewise function. So we use a brace, and then inside that brace, we're going to split up, we're going to split this up. Okay, so how do you do this? All right, so first, and these are just suggestions, you could figure it out differently, but it really starts with visualizing the graphs that we're dealing with. Okay, so let's take a look at what's inside of the absolute values, okay? This is a line. Okay, so this is and if you rewrite it forwards, so you could see it's an mx plus b form. All right, so this is a decreasing line. Okay, that's a decreasing line. Okay, and so let me find the 0. All right, so this is a decreasing line. So if I find the 0, all right, so let's say that's the x-axis. This is what my line looks like. All right, and if I want to find this point on the x-axis, that would be the 0. I would just take negative 2x plus 7, set it equal to 0. Okay, so 7/2. Okay, so 7/2 is right there. Okay, now this is the graph of this line. But when you put absolute values on a line, it becomes a V. And so in order to obtain the graph of this, or a sketch of the graph of this, which is going to help us figure this out, that's why we're doing this, to just figure this out, we have to reflect any negative parts here. Okay, now this part here to the left of 7/2, we're going to keep that part of the line. Okay, but this other part here, all right, we're keeping that, but then we're flipping. We're going to flip that. So it's going to flip up like this. Okay. So that is what the graph of this looks like, or the sketch of it. All right. So, all right. So this one that we're keeping, the graph of this, or this part of the graph of this lines up perfectly with the original line. So I'll just say, you could write like either form, like backwards or forwards. I'll just go like that. Okay, so that part is just that line. But then this other part we got from flipping the negative part of the line. Another name for flipping here is reflecting over the x-axis. And the way you do that to a graph is you put a negative. You multiply its function by a negative, the whole function. Okay, so now what we've got going on here is two separate like parts to this graph. Okay, so I'm just going to copy these two things down. So we've got negative 2x plus 7. Okay, and so right now the graph is split into two sections. All right, so the graph is split into two sections. So now you have to tell your reader, when you're writing down the pieces here, you have to tell your reader which section you're using it for. And this is where the inequality comes in hand. So let's say that this is section 1, this is section 2. Section 1 is described like this. X is less than or equal to 7/2. Okay. That's this whole section to the left of the border. And then to the right, we would say, oh, I'm going in a lot of order, but let me do that. Yeah, so to the right, this is x is greater than 7/2, okay? But then what we're using is the negative of the original, of the line. So I'll distribute the negative here, but you don't have to, that's optional. And this is the answer. Guys, another version of a correct answer would be that this one is just less than with no line, and this one is the greater than or equal to. You just need an or equal to next to one of them. Okay, now this second one, rewrite as a piecewise function. So again, but this time we're not doing the absolute value of a line, we're doing the absolute value of a parabola. But the process is the same. We're gonna find the zeros, just do a sketch of the graph. Then that will help us figure out which parts you are just keeping the parabola equation on, and which parts you're negating the parabola equation on to make it flip. Okay, so anyway, so we've got, all right, so I'll set up what I need, or what I want. Now with a line, guys, absolute value of a line, piecewise, is at most 2 parts. But absolute value of a parabola, piecewise, will be at most 3 parts. Okay, so I'm leaving space like for 3 separate parts, although there could be less. Okay, so now I'm going to take this, x squared minus 2x. All right, so this is a parabola, and it opens up. All right, parabola opens up. Okay, so I know like what it looks like. Now let me find the zeros. Let me find if and where it crosses the x-axis. And then I could do a nice sketch and figure out what to flip. So x squared minus 2x equals 0. Okay, so in my head, I'm setting each of these equal to 0. Okay, so those are the zeros. So that means my parabola opens up and it crosses the x-axis twice. Okay, so if it's opening up and crossing twice, it has to look like this. Okay, so this is where I'd have 0. This is where I'd have 2. All right. Now, for the absolute value sketch, guys, we are keeping, let me split up into sections. First, okay, so we got 3 sections. I'll say this is the first section, second section, third section. Okay. Guys, the first section, we are keeping the same graph as the parabola. Okay, the sketch of the absolute value would line up perfectly with the sketch of the parabola. The third section as well. Okay, same idea. But this here, we're gonna flip over the x-axis. All right. So what we end up with when that one flips over, it looks like this. Okay, so the blue graph is the graph of the absolute value. Okay, so we could see that it is in 3 separate parts, or 3 parts that we could separate. All right, now the sides that we're keeping, we just are using x squared minus 2x as our pieces. Okay, and then in the middle that you flipped, that's going to be the reflection of that parabola. And you reflect by putting a negative out front. Okay, so we see those 3 pieces. So this first one, x squared minus 2x. Now, how do you describe section 1 with an inequality here? It would be x's that are less than 0. Okay. Now, the middle, I'll distribute the negative. Negative x squared plus 2x. That is for 0 less than or equal to x less than or equal to 2. That's how you describe this middle section with an inequality. Okay. And then the last one is for x is greater than 2. Alrighty? So there it is. All right, now moving on. Okay, so the next 2, you are given a piecewise function. You're not writing one, you're given one. And you are asked to sketch the graph. Okay, so first, we want to look over here at these, okay, these conditions. Okay, so we have, all right, so this is, section 1. This is, let's say that is section 2. Guys, what is the borderline between sections 1 and 2? X equals 0. Okay, x equals 0 is the borderline. All right, and you could just see it here. Okay, that's where the first section stops and the second section starts. Therefore, that is the border. Okay, so we're going to keep that in mind. But first, I'm going to draw each of these separately. And I'm going to use a pencil so that I can erase. Okay, so I'm going to draw each of these separately. So this is what e to the x is looking like. 1. Okay, and then this is what x to the 3rd looks like. Okay, now I'm going to put in the borderline, which is x equals 0. Okay, so that's the borderline. All right. And then I'm going to erase the side on the borderline that I don't need, like from each graph. So, guys, they're telling us up here to use this graph for section 1. Section 1 is where all of the x's are less than or equal to 0. So section 1 is the second and third quadrants, basically. That's all that we're using this for. So I could just go like that. Okay, now you've got to decide if there is an open or closed circle on the borderline. And this is where this or equal to tells you. So x is less than or equal to 0. Well, the other one actually we were plugging in as well. Actually, never mind. All right, it doesn't really matter, guys. Oh, no, yes, it does. Sorry. I'm losing my train of thought. All right, we need closed, all right, because it's an or equal to, so we're including it. I got ahead of myself. Now, you need the y value after you decide open or closed, and that y value is 1. Okay, now this one, we don't need this side. Okay, now what kind of circle on the borderline? Strictly greater than, so now open circle. And that y value, that's right at the origin, that y value is 0. Okay, now over here, this is our answer. Okay, so this is the x-axis, that's the y-axis. Okay, the y-axis happens to be our borderline. Okay, so and I just transfer these. So just imagine putting these graphs on top of each other. And we got all right, so say that's 1. That's an asymptote. And then open. Okay, guys, that is the answer for that first one. Second one, we're doing the same thing. Okay, so this is section 1. This is section 2. This is section 3. Okay. All right, so the first section goes from 0 to 1. The second section from 1 to 4, and then the last section is everything beyond 4. That would be the third section. So let me graph each of these first, and then I'll erase what I don't need. Okay, so we got okie dokie. So the first one is square root of x. So square root of x looks like that. And then we got 3x plus 1. Okay, guys, here's a nice quick way of sketching a line. Okay, that's a line. What's the y-intercept? The y-intercept is 1. All right, so I'll just put 1 there. Now, ask yourself, is this an increasing or a decreasing line? It is increasing. So there's the y-intercept, increasing line. So that's going to help you like know that it looks like this. But then you just need this x value. That is a 0. That is a root. So you would just take the line and set it equal to 0. So x is negative 1/3. All right. And then the last one, 1 over x, looks like this. Okay, now let's figure out what we need. So we're using this graph only in the first section. So what are the borders of the first section? The borders of the first section are 0 and 1. All right. So in the first section, we've got these borders, 0 and 1. All right. And I don't need anything outside of those borders. So there's that. Okay. Now, what kind of circles? Okay, so less than or equal to, so 0 is less than or equal to, so closed circle there. And then less than 1, open circle. And then you just got to get the y value. So you just take 1 and you plug it in. The square root of 1 is 1. Okay. Alrighty, now this next one, I'm using the line for section 2. What are the borders of section 2? The borders of section 2 are 1 and 4. Okay, so let me actually extend this so I have some room. Okay. Alrighty, and all right, putting in the borders. Okay, so the borders are 1. All right, x equals 1, x equals 4. Okay, so I only need what is between those borders. Okay. Now what kind of dots? Closed, open, and now we need the y values. Okay, so for the y value at 1, plug it in here, we get 4. For the y value at 4, plug it in, we get 13. Great. Okay, and now this one, we are only using beyond 4. For x is greater than or equal to 4, we're only using on that last section. So let me just, so the only border for the third section only has one border, and it's x equals 4. And we're only using everything that is past it. Okay. Okay. And, okay, so what kind of dot? Okay, closed, and then the y value, how would you get that y value? You would take 4 and you'd plug it into 1 over x. So you're getting 1 over 4. Okay, guys, now we're lining up all of these. We're putting them all together. And we just have to make sure that the dots on the border lines, like whatever should be higher is higher, whatever's lower is lower, etc. Okay, so I'll put it all together. Oh, I just realized that the music is on. Okay, so we've got our border lines. All right, I'm not going to do the border lines if that's okay. Okay, so from 0 to 1. All right, so let's say like this is 1. All right, so from 0 to 1, we're looking like this. Okay, so I'm copying this first one. All right, and then that y value is also 1. Okay, and then from 1 to 4, all right, let's say that 4 is here. Okay, so from 1 to 4, we've got this line segment. All right, so from 4 to 13. All right, so let's say that this is 4. And let's say that this is 13. All right, so this one starts with a closed circle on 4, or at 4, and then an open circle at 13. Okay, and that's just a straight line. Nice. Okay, and then finally, we've got in the last section, which is just beyond 4, we've got this one. So this is so I'll put a 4th. It's not drawn to scale. All right, but let's say that a 4th is there, just so I have room. And then we go like this. All right, that doesn't look great, but so guys, this should not cross the line. Now because this is an asymptote, we have to label this asymptote with its equation, which is y equals 0. Okay, is the equation of the x-axis. Okay, guys, there it is.